Hi everyone, today I will share with you my video on cupellation. This is not a tutorial, do not repeat anything shown in the video. Cupellation is an ancient metallurgical method for refining and extracting precious metals. Before the invention of Park's process, it was the only way of separating silver from lead. As such, it was done on industrial scale. Nowadays, it is still used for fire assays and in small mining operations. It works by placing the alloy of precious metals with lead or bismuth and base metal impurities into a dish made from bone ash, magnesium oxide, or Portland cement. The alloy is then heated in a furnace where it melts and exposed to hot air oxidizes. More precisely, base metals in the alloy oxidize and absorb into the cupel. Silver, gold, and the rest of precious metals that do not oxidize are left as a small bead at the bottom of the cupel. To pull this off, you need a cupel, that is, a dish from bone ash or magnesium oxide, and some kind of furnace. I have neither of those things, nor do I feel like purchasing them, so I improvised. A warning to any viewers who do assaying, avert your eyes because this is going to be scuffed. I plan to use smelting and cupellation to extract precious metals from electronic components, but first I need to figure out if I can actually pull off cupellation with my setup. To run a test, I weighed out 0.37 grams of silver and added to it 6.5 grams of bismuth and melted them together. I chose bismuth instead of lead because it is nowhere near as toxic and behaves similarly enough to lead. I believe the higher price is still preferable to heavy metal poisoning. The alloy had an interesting looking dark green oxide layer. It would appear that adding silver to bismuth does not interrupt with the formation of colorful oxide layer. Then I crushed some bones I calcined by tossing them into a central heating wood-burning stove. They are mostly calcium phosphate and have a crumbly chalk-like structure. After crushing them, I sieved them through a sieve. To construct an improvised cupel, I packed the bone ash into the bottom of a cut-off steel gas can. I had planned to heat this cupel inside a charcoal-filled, perforated paint can, but there weren't enough holes for good airflow, so I abandoned the idea. Instead, I went with a simple fire pit. I waited until the cupel was heated, then I placed in the metal prill. Despite being unorthodox and all kinds of wacky, the setup appeared to work. I ran it for half an hour, and then I let it to cool and weighed the bead. Its weight was reduced from 6.9 grams to 1.6 grams. There was still a lot of bismuth in the alloy, so I decided to try cupelling with a MAB gas torch. I turned the can around and moved the bone ash into its concave bottom. It was slow, but it too appeared to be working. Yellow coloring of the bone ash you see here is bismuth oxide. Ideally, I would run cupellation until only silver remained. But it was going really slowly, and I have already seen that it works. Now, I wish to know if I had lost any silver during the process. To do so, I decided to do an acid assay on the remaining metal. I dissolved the bead in acid and precipitated silver chloride with sea salt. Then I filtered it and dried it. Afterwards, I reduced silver chloride with lye and sugar method. As a source of reducing sugars, I used honey. After decanting the liquid and thoroughly washing the silver powder, I dried it and weighed it. And the mass was 0.349 grams. In the process, I had lost 0.023 grams or 22 milligrams of silver. I believe it is obvious my setup needs some optimization. I already have some ideas. If you have any of your own, please comment them down below. I believe I should be able to process ground up MLCCs and IC chips. Thank you for watching. Like, subscribe, stay in the shade, and see you next week.